Hi, good afternoon. My name is Mufaya Akiwa. Uh, I'm an AI engineer, and today I'll be taking us on building image generation applications as well as using low-code platforms like Power Automate. I'll walk us through this slide and provide practical examples to the best of my ability, and hope that you can understand what we're going through today. Building image generation applications. What do you call an image generation applications? Today, with the invention of AI into our day-to-day activities, it has made it a lot easier to generate so much content with just a single text. With a couple words or sentences, we can do so much. So when you say image generation application, what you actually mean is an application that can generate images from text. Now, that is what an image generation application is. Today we have platforms like DALL-E and Midjourney, which allow us to generate images from text or prompts. Our learning objective today will build an image generation app using Python and an Azure OpenAI, and we'll deploy a model DALL-E 3, and then we'll generate an image based on our desired prompt. We'll also define the application boundaries, implement meta prompts to establish safety guidelines and content restrictions for your image generation applications. We'll understand what DALL-E is and the integration. So how we'll use DALL-E as the model behind our image generation, and then we'll apply it to real-world solutions. So we'll develop practical image generation solution for education, creative industries, and business applications. So what is image generation? Now, image generation, like I said before, is the ability to use text and prompts to generate images for different use cases. Could be for medical technologies or for tourism to game development. We can develop these images to teach students to help students understand basic concepts a lot better. Now, the two models, like I mentioned before, we use it for this class would be DALL-E and Midjourney. These are already existing image generation platforms that allow you to generate images from text or prompts. Now, we'll learn how these models work and how to integrate them into our application and also establish boundaries safe for effective use. Now, it also boils down to AI ethics, where we have to make sure that we're using AI and like models responsibly without bias and so on. Now, the key topics would be image generation fundamentals, DALL-E, and mid-journey capabilities, building practical applications, and safety and content control using meta prompts. Now, why build image generation applications? So image editing and synthesis. So we can generate and modify images for creative projects, marketing material, visual content across multiple formats and styles, right? We could use it for industrial applications. So we apply those images for medtech, for visualizations, for tourism and destination preview. Like if you are trying to get an image or a message passed across, and the best way to do so is via, sorry. So if you're trying to pass a message across and you need an image, you could basically just generate that image with a simple prompt specifying what you're trying to achieve. That it could be uh the tallest building in Tokyo, and with that basic prompt, we will have an image generating illustrating the tallest building in Tokyo or the tallest building in Nigeria or and so on. And then it allows for rapid prototyping. So because of how direct and in a sense easy it is to generate those images, we could quickly visualize concepts, ideas without having to traditionally design those resources. It accelerates our creative workflow. So we've gone from having one person design an image, we could take hours or days to designing that image in minutes. And then we move on to more technical aspects of the project. So if you had a proposal to develop engineered images to illustrate your point, instead of spending time looking at the internet, you could just go to a model like DALL-E and Midjourney and get it to produce the exact image you're looking word for word with details, and you can even modify it to get better and better and better. Now, our scenario today is we for the use case would be Edu for All. Now, this is a educational platform, right, that enables students to create custom images for their assessments. So the students will be able to generate illustrations for fairy tale, design them characters, visualize concepts. And for example, when we're studying world monuments, students can place famous landmarks in a creative concept. And an example would be the prompt below, the dog next to Eiffel Tower in the early morning sunrise. Now, this is an example, and the image to our right shows exactly that. This image was generated purely on the prompt below, right? So this is a dog next to the Eiffel Tower in the early sunrise. So this illustrates the point of how efficient these image generation applications are with just using a single prompt. Now, we could go further and add more detail. We want the dog to be dark. We want the dog to have bright eyes. We want the dog to close the mouth and so many other points. Now, so we're going to take a deep look into what the DALL-E model is. Now, like I said, DALL-E is an image generation app. It's a generative AI model that creates images from text. So it combines two powerful models, the clip and the diffused attention. Now, what the clip model is, it generates embeddings. And embeddings in a sense is if you have a prompt, and I hope you have come across embeddings before, but embeddings in the sense is if you have a sentence, when you say you embed that sentence, you're converting that sentence into not a numeric representation, right? So that's what that clip model does. It converts the text or our prompt into a numeric representation of the data from both images and text, creating a shared understanding space. Now, basically, all that does is the first stage. Now, once we send our prompt in, that clip model converts that prompt to embeddings, and embeddings are used because it's easier for our model to understand embeddings. It's a like an understanding space, right? So the model now processes the embeddings and not the original text. Now we move on to the next aspect, which is diffuse attention. This diffuse attention transforms the embeddings into actual images through a sophisticated generation process. Now we'll look at that generation process later on in the class, but I want you to understand how the model works. Now we go from our clip model to the diffuse attention. We transform that embeddings which we generated by the clip model into images, right? And then finally we have that image output. So we produce a high quality image matching the text description, like a cat in a hat, dog with a mohawk, or a dog by the Eiffel Tower in the early morning, as shown in the previous slide. Moving forward, so we'll look at the architecture, a deep dive into the architecture of DALL-E. Now, DALL-E uses an autoregressive transformer architecture. What that means is that it generates the image one pixel at a time. Now, pixels are the most minute or the tiniest element in image generation. Now, a combination of so many pixels make up our image. But if you could zoom into an image, you could see the little pixels. If you zoom in well enough to an image, you can see those little pixels that make up the entire image. Now, so autoregressive transformer architecture means that it generates images one pixel at a time, and then the prior pixel that it generates informs the next it forms the next pixel, right? So it's like the first pixel is generated and stops at a certain bounding box. And then based on that location, it can inform the next pixel where to start. And then that next pixel now ends before informing the next one where to start. So the image goes from one pixel to another, and it does this by passing through multiple neural network layers until the complete image emerges. So we're going to keep building pixel after pixel after pixel. And mind you, it is rapid. It takes seconds to generate, not up to minutes. So it's as quickly as possible. So that process, the autoregressive transformer process, allows DAL-E to control attributes, objects, and characteristics with remarkable precision, right? And other versions of DAL-E, DAL-E 2 and 3 offer even greater control over generated images. So now the architecture goes from the text input, process natural language prompts, then we have the embedding generation, which is done by the clip model, which we said previously. The embedding generation converts to numeric representation, and then the pixel generation creates image pixel by pixel before we get our final image, which is a complete high quality output. Now we'll look also at Midjourney, as we said, it's also a text generation application. It operates similar to DALL-E, generating images, text via prompts, and it excels in creating artistic, styled images with unique qualities. Now, the key points for this would be its prompt-based generation. It uses text description like the DALL-E to create a distinct artistic flair. It's known for producing the artistic style, it's known for producing images with painterly, illustrative qualities that appeal to creative professionals. So you could say it's a lot more artistic than DALL-E. And then it allows for a community platform. You can operate it through Discord, which is another platform, not for generation, but it's a community platform where people go to post ideas and interact and foster a collaborative community for creatives, sharing techniques and results. So it allows you to share your images across that platform as well as other platforms. Now, I'm for this class, we're going to walk through a brief practical, and I will show you what a text generation application looks like, a local text generation application looks like. We will generate an image and we'll also view that image and see what we generated. We won't focus too much on the Python code, although I'll try to explain to you what each code does and how we get to our generated image. So the step for setting up a development environment locally. So we'll install our libraries, right? We'll install our libraries. We'll create an Azure OpenAI resource. I'll also show you that. We'll configure the environment. So we'll create a .env file and add all our keys and our endpoints so that we're not exposing any of the valuable information to the main application file. And then we'll start up our virtual environment. And by the time we've done all this entire setup, we'll have a text generation app that we use prompts to generate images from. So to build our first application, create an application. So creating an image application requires us to fill essential components. The core workflow involves configuring the Azure OpenAI client, generating the image through the API, and handling the resulting image data. Now, this is basic code, so I don't want you to focus on this, but this is basic code, and I'll show you what it looks like when we actually have it down in an IDE, an integrated development environment, where we can actually start to develop our application app. All right. So we'll talk about the generating image code, right? And like I said, I'll show you in the practical just to follow. So image generation API accepts the text prompt, the size, the specification, and the number of images to generate. The response contains a URL or a mostly a URL or a directory showing where the generated image is and which we can either view or download locally. No, so we need to understand what the generation parameters are. So we have a prompt, which is a key variable in our generation scheme is a prompt. This is the text that describes what image we want to do, what image we want to generate. We need to be specific, descriptive for the best result. So it could be bunny on horse, holding a lollipop on a frog, meadow, a froggy meadow where it grows dandelions. This is a very complex prompt, but it's direct. So you know what we want to build. And if anything, I would use this prompt for as a test for our practical because I like the way it looks. And then we will specify the size of our image. So we want to specify the dimension of the generated image. And the common sizes are is 1024, 1024, 512, 512, or 256 by 256. And these are the pixels dimension depending on what we need. So if we want it very detailed, we can use 10, 20, 1024. And then as the size, as you can see, the lower the number, the lower the pixel size, and the smaller the image generated. So the end count also specifies the number of images we want to generate from a single prompt. So we could generate multiple variations to choose the best result. And then the temperature is also a very important parameter, controls the randomness of our outputs. Now, if it's zero, because it goes from 0 to 1, 1 being the highest and 0 being the lowest. Zero means it's very deterministic. Zero means that we can determine or exactly say what the output will look like. And one means that it would be as random as possible. So we have no idea what our output will look like. But the usual default is 0.7. So this is just like a middle point. It's not deterministic at all, but it's not too random. So it's just neutral enough. So a lower value produces more consistent results. If you want to have the same result over and over and over again, you can set our temperature to zero. But is best advice keep it at 0.7 because it allows you to mess around and allows you to look at different outputs, different outcomes from your single prompt. It gives you variety in a sense. So now we're looking at how temperature affects generation. So like I said, temperature is very important in honestly any form of coding that you do, but for our image generation, it's important because it affects the consistency of the image generated. So we can run the same prompts, and normally you should know this that AI models are non-deterministic in nature. You could write the same prompt, and it would give you 10 different answers the same every single time. So you could write what is something simple, but it will not give you that same answer unless you put the temperature as zero. Now, this is where temperature is very important because it controls that variation. So you have high temperature, it produces more varied creative results, right? Each generation differs significantly, offering diverse interpretation of the same prompt. So we could have it would give us as different variations as possible, as different variations as possible. You could ask it what is the best iPhone, right? And this is an example, and it would answer you with a different sentence every single time. But if you now wanted to answer us with the same answer, so if you say what is an iPhone and you wanted to tell you the same sentence every single time, you use a low temperature. This one creates a more consistent deterministic output. Images generated from the same prompt closely resemble each other, maintaining the core element. So, like I said, if you want to have this image on the orange image to our left, if you want to have the same image over and over and over again, we could use a temperature of 0 to 0.3. We could just change maybe the colors or change, maybe reduce this hill or not, but it will still it'll look exactly the same. But if we want to have different variations of this same image, we'll use high temperature. And what that does is you have image looking like the first one, but you have a different color. The mountains look similar, but the colors are different. The one below has a circular object. It could be the moon or the sun, but it looks slightly different. But you see that the idea or the concept behind the image still is the same. We have mountains in the background, so topography, and then we have a background image, and the colors are different because we have changed the temperature. So we could, if you want different variations again, use high temperature. If you want the same image over and over again with very little to no variations, use a low temperature. So advanced image capabilities. Hold on. All right. So at this point, I'd like to pause and then go through the practical, and then we'll continue back to the slides. So to continue, first of all, I'd like to work us through Azure and how we get our DALL-E model deployed, and we make reference to it in our application file. So I'll start with sharing my screen, showing you the Azure platform. All right, so here we are. This is Azure, Microsoft Azure Foundry, and this is where you get to play around with different models. You can make agents, you can fine-tune those agents. I have a model catalog. It shows you the different types of models, but today we're going to focus on a text generation model. So there are different types of models you can decide to, and they give you they categorize them for you based on quality, safety, cost, throughput, like the output. So there are different outputs. It goes on and on and on. But like I said, we'll look at a text generation output. So to do that, we go to the bottom and we go to models and endpoints. Now, I've already deployed the model we're using today, but I would like to just show you what it looks like to deploy a model from scratch. So we go to model and endpoints, and this is after you have, and if you're not familiar with the Azure platform, you have to start up a project, and that project will now allow you to deploy models within that project, right? So we will deploy a model today, and then this will be our base model. So we're going to search for DALL-E, and it should show us this. So this is a text to image model. So we're going to click on this and we'll confirm. By clicking confirm, we're going to deploy our model. And this is why we have the model deployed right here. So it succeeded. This is the version succeeded when we did it today. So we're going to click on that model to see the details about the model. All right, so now we're looking at the model's information. We have the endpoint. So this is our target URL, the API key. We have the name, the deployment type, created on. We look at the model name, the model version, the date it was created. And this is a sample of how to access this deployment, this model we've deployed, right? So now I just wanted to show you how I get the information for the model. So now what we're going to do now is we're going to create a text generation application and make reference to this model that we deployed as our AI model. So all we're doing is going to encapsulate this model with code and get it to generate models for us. We could do it here playing using the open playground, but I want us to use Python code so we show how you could do that with Python, and then how you can also do that with low code platform, right? Right, so I'm going to stop sharing now, and then I'll show you what our text generation app looks like using my Visual Studio Code IDE platform. I'll proceed to share my screen. Now, for the purpose of this class, I have gone ahead to set up our environment. I have done the essentials so that what we'll really do right now is look at what we need to do and generate our image. But like I said, I'll walk you through the code file and then you can try to understand what I'm trying to accomplish here. I'll also walk you through using the playground platform, and that will come on later on when we're trying to use a low code platforms to generate images. Just give me a second. All right. So I will walk us through. So in the slides, you talked about setting up your environment. Now, if you are developing anything on a platform like this, it's usually best to start up with a virtual environment. This helps you isolate all the libraries and dependencies that you need to run your application as smoothly as possible. Now, so basically what you would do for your first step is you'd create your virtual environment. And the code to create a virtual environment usually is Python make venv. All right, I already have my virtual environment set up, so I'm just showing what the code is. So after you run this code, then you proceed to run the name of your virtual environment first, script, activate. Now, what this does is it activates your virtual environment. And now, if you look here in this part, you can see that my virtual environment, this is what it stands for. VENV stands for virtual environment. It shows that my virtual environment has been activated. So now we can work. Now, after that, the next step for you, the next best thing for you is to install your requirements file. Now, the requirement file usually just composes all the libraries and dependencies that you need for your application to run smoothly. For this application, we have OpenAI, Python.env, click, rich, pill, and request. We don't need to pay too much attention because requirements of the libraries vary depending on what you're trying to accomplish. Yeah. But for this one, this is what we need. Now, the next step for you will be to install your requirements into your virtual environment. Like I said, we're trying to isolate our development environment so that everything we need is in this virtual environment. So as soon as we activate this, our app can run. So usually the next step would be to pip install read requirements.txt. Now this is going to read our requirements file. So you're going to read this file, right? And then it will install all the requirements. Now I'll press enter. I'll press enter here, but it will show us that requirements already satisfied. See, requirements already satisfied, requirements already satisfied, requirements already satisfied. And this shows that I've installed our requirements. So I'll clear this and then I'll proceed. So now that we've installed our requirements file, we'll go to our .env file. Now this is very important because if you're developing an application, it's best to not leave your OpenAI endpoint, API key, or your version, any of these details, it's important that you do not leave them in your main application file. Because if somebody comes across any of this information, right, they have access to your model that you deployed and they can use it for malicious intent. And they can use it to start developing things which could in return lead Microsoft or Azure to block your account because now you're doing malicious activity, right? So it's very important to use your .env file to hide all this valuable information. So now we'll look at our main text generation application. Now this is a beginner-friendly text application, and a script like this always starts with you import your variables, your libraries, and your dependencies. So we're going to import our OS, our system, time, base 64, pathlet, typing, our .env. This allows us, right? This allows us to retrieve the information from our .env file. So that's what load.env does. And I can show you that also in our requirements. So it's a library that we need to install. So imports request, another library, rich, another library, and these are other factors in our rich library, the prompts, the table. Now we also need to import our OpenAI and our Azure OpenAI. So this is our client object. This specifies what clients we're going to be using to interact with our model or where our model is being hosted on, which is an Azure platform, the Azure platform. So this is our default prompt, a watercolor skyline, and this is our default size. Now, I would, when we start the application, we will be able to specify what type of prompt. And like I said, I want us to use the one from our slide. So when the time comes, I'll briefly stop sharing my screen and I'll get us that exact prompt. And then we'll run it and see how the image turns out. So we load our config. So this is to load our environment and our environment details. We'll define them. Now, like I said, there's no point to look too much into what the different factors do, but I just want you to know that all this code makes our text generation app. So our endpoint is get env Azure OpenAI endpoint, which is this right here. We get our API key, our API version, and then we'll create our client. Like I said, our client is Azure OpenAI, and our Azure endpoint is equals to endpoint, this one. API key is equals to this, the version is equals to this. So now we have created our client object. So defining different functions. So this is an ensure output. So this ensures our output. This saves our image is another function. This is generate the image, and then we deploy. And then this just defines our main application. So we can look into detail, but like I said, all this is just basic knowledge, basic text code used to generate an image. And this encloses our entire application. So I will go ahead and start to run our file. And to run that in Python using is basically this code, Python, and the name of our file, image.py, right? So we're going to run this, and it says enter an image prompt. Now I'm going to briefly stop sharing my screen. I'm going to well, there's no need for that. Just give me a second so I can get that prompt. So this is our prompt. Let's see if I can fine tune it a bit to make it look better. Bunny horse holding a lollipop on a froggy meter where it grows than before. So, all right, so this is fine. So I'm gonna do this. All right, so I'm gonna do this. So we have our prompt. Bunny on horse holding a lollipop on a foggy meadow where it grows dandelions. So I'll press enter. It says what is our size? We use 1024 times 1024, right? And then we say, let's do 2 images. I didn't specify temperature. 1 second. All right, I'll implement the temperature later. So we'll do 2 images so we can see what the different outputs look like. My bad. So we need to do just one. So I'll run this again. Paste our prompt. 10, 24. Just do one. So now our application is loading and it has sent the payload to our model in Azure. And now what will happen is Azure will process our prompt, all our requirements, the size, and then it will respond to us with an image based on that prompt. So now we have a generated image and class 2015-1202. So we go to our outputs folder and we look for our file. This is it. So So here we go. This is what our application, this is what our image looks like. A bunny on a horse holding a lollipop with surrounded by dandelions, where it grows daffodils, daffodils. So this is what the image generation looks like. Now this is a basic image generation application, and we have used our Azure model DALL-E to generate this. We can try something else just for the course of this class. So let's come up with something good. Maybe something more, uh, let's see if it knows what Todd Milan Bridge looks like. A skyline view with the main wow bridge in layers. And as you can see, I'm trying to specify so it knows exactly what I'm talking about. Okay, I'm gonna say the same thing, 10. Let's do smaller. Let's do 5 2 times 5 2, 512. One image. Uh, all right, so we go to narrow, run that again. I will just get this. And then we'll do 10, 20 times 10. All right. Image. See, because it's not part of the dimension that's specified in code file, so that's why it didn't work. So if we're lucky, we get our desired output. Let's see what it looks like. Uh, this is actually brilliant. I actually like this. It's not exactly, but it's close enough. It's actually close enough. So this is what a text generation application looks like. And like I said, you could generate anything you could think about as long as you are detailed in your prompt. You're very detailed in your prompt and it shows you exactly what you wanted to do. We can go ahead and start to modify this, but we won't do that for this class. We won't do this right now. I can show you that when we start to use a low code platform, which we'll get to as we proceed with the class. So this, like I said, is a Python script or an application that allows you for text generation. All right. And that being said, I hope you like what this looks like. I would love to show you more detail, but it looks really nice to me. And let's see if I can trim this down so we can get a better view. Okay. Yeah, this looks very, very, very nice. Very nice. All right. So moving on. I hope you enjoyed that like I did. So moving on, I'll stop sharing it and I'll continue back to the slides. All right, so we're talking about advanced image capabilities. So like I was saying, you can further edit those image. So you can edit an existing image. You can provide an existing image and place a mask, identifying the area to change and a text prompt. For example, you add a hat to the bunny by masking the area head. All right, so I'll try to explain that further as we go along. So basically what it's saying is if we decided to further edit that image, the one of the Nigerian skyline, we could go ahead and further edit it so we can provide the image. I say, okay, I need to fine tune the bridge. It doesn't look exactly how the Third Bridge looks. I want it to be more authentic, more Nigerian, more have that Nigerian feel to it. So we could also do that. We could create variations. So we could have different angles of the Nigerian bridge. We could have one that's looking from the mainland towards the island or from the island towards the mainland. We could have one looking from from a boat view, and I think we should do that as well. So uh, a boat, a view from a man in a boat looking at the Tall Milan Bridge. So we should do that. So that's a different variation of the image. And then we can synthesize multiple images. We can combine multiple images into a single image. So we could add, so let's say after we produce the different images of the Tall Mila Bridge, the one from different angles, we could have all those images combined to make one major image of the Tall Mila Bridge. So this is our advanced image capabilities. Now, so this is where trying to understand image editing example. Now we have the base image, and this is just to illustrate the point. We have the base image. This is an original launch with the pool. So we add a mask to specify the areas that we want to modify, right? So we add the mask on that base image, and then we add the prompt to specify, okay, I want you to modify the image so that it looks like the final result. And if you look at the sequence on the code below, it says response client.image.edit model ChatGPT, the model that they want to use. For us, it could be DAL-E. And then image, open our image source. So this is the original image, the sunlit lounge. And then we add a mask to cover or specify the image, the area that we want. So we want to modify this area, this middle area. So we're going to add a mask in a sense, and then we now do prompt. So we're going to add a prompt that says a sunlit indoor lounge area with a pool containing a flamingo. So I've modified this image from the original pool in the lounge to an image with a flamingo added into it. So this is to illustrate the point that you can modify an already existing image. So you don't necessarily have to generate the image from scratch. Sometimes we can just get our image, and if you have an image or if you're working on an image but you want to take it to a new level, we can provide that image. And this is done usually, we could just do this with code. So we can narrow it down, specify to the image directory, and then modify our code like so down here and then use that to generate a new image with our new design. So now we're going to implement safety with meta prompts. Now, meta prompts allow us to establish boundaries for application. They ensure that whatever generating is appropriate and safe, right? They're positioned before the prompts to control the model output. So they define guidelines, they establish clear rules for appropriate content, target audience, and styles. So now we don't, if our a scenario app, the Edu for All, is for children, we don't want them to have access to inappropriate content. We don't want our model generating inappropriate content for the kids because, like I said, or I will say, as vast as the potential of AI is, it also has the potential to produce harmful content, to be biased, has the potential to hallucinate content, which hallucination in a sense is just making up things where there was no ever existence. So like it could make up a president for Nigeria, but we all know that the current president is Tinubu. You could say, oh, it's is somebody, right? It could be soul, and that's hallucination, so it's lying. And this goes back to what the model is trained on or how it was trained, and it varies because different models are trained differently. So back to meta prompts, they define guidelines. You can use them to create a disallow list. So let's say we don't want certain things to come out in our output prompt. So we say we don't want anything related to violence, adult themes, inappropriate material, and then we can combine prompts. We can merge our different meta prompts into our main prompts, which allows us to, excuse me. All right. Apologize for that. So we can merge our different meta prompts with this user input to create a single control generation request. So if we specify different meta prompts, okay, we say this meta prompt is so that we don't allow violent to adult teams. The next one is okay, it needs to be the next meta prompt could be, oh, we need to fine tune to make sure that this meets our guidelines or the regulations so that whatever the output is suitable for children. So this is a meta prompt implementation. Now it says disallowed list. This is an example of a meta prompt, right? It says swords, violence, blood, gore, nudity, sexual content, adult themes. And this is a disallowed list. So whatever, if the model has even the slightest idea to include any of this, because of we have specified that this is a disallowed list, it won't be able to, right? So we say a meta prompt, okay, another meta prompt is you're an assistant designer that creates images for children. The image needs to be safe for work and appropriate for children. The image needs to be in color. The image needs to be in landscape orientation. The image needs to be 16:19 aspect ratio. Do not consider any input from the following that is not safe for work or appropriate for the children. So now what we've done is we've defined this first meta prompt, this allowed list. We've used it in this second meta prompt. So we're specified, okay, so make sure that you look through the disallowed list, right? And then we'll now go to another, our final main prompt and specify that, okay, using the meta prompt, right? Create an image of a bunny on a horse holding a lollipop. Now, I hope you understand what we've done here. We've done two different meta prompts and we've included them one after the other into our main prompt. So we included this allowed list into this first meta prompt and this meta prompt into our main prompt. So now this approach ensures that all generated images adhere to your safety guidelines while still allowing creative freedom within appropriate boundaries. So we're setting boundaries, we're setting limitations, we're restricting content, the kind of content generated so that it's suitable for our use case and for our clients and our students in a sense, in our current sense. So sorry. So this is an example of a student assignment. So this is a monument visualization. A creative monument project. Students will generate an image of the world monument in creative context. The assignments encourage creativity while maintaining educational value and appropriate content. Now, you see the requirements, select the famous world monument, place it in an imaginative context, use appropriate meta prompts for safety, generate multiple variations, document the creative process. Now, we could use the meta prompt method, which we used here, or we can go straight and say the arc the temple with a child and a teddy bear. And this is what this image shows right here. We have the child and the monument. Now, provided we are shown the slides, it would be very nice for us to go to platforms like DALL-E, Midjourney, and then, generate a prompt, right? So now we'll be talking about building low-code AI applications. Now, although I don't essentially have access to the Microsoft Power Platform, I will show you how to implement or how to develop text or an application, an image generation application, or use an image application model, an image generation model, right, for image generation purposes without using code. So basically, what Microsoft Power Platform does is a platform that allows you to develop apps using little or no code, right? With basic prompts, you can generate applications. So unfortunately, I can't access it right now, but I'll try to explain it to the best of my ability. So what we're going to understand from the Power Platform, you have to understand what Copilot is, and Copilot is just Microsoft's own AI model. So you learn how to use AI assistants, enhance low code development through natural language interaction and automated solution generation. Basically, like we said, using Copilot, using prompts on Copilot and the Power Platform, we can generate applications, right? We'll build apps with AI and we'll generate a student application tracker app using Code Pilot in Copilot in Power Automate with Dataverse integration. Now we'll look closer at what all these terms mean, Copilot, Power Apps, and Dataverse later on in the slides, and it will help you understand what I'm trying to say. So we're going to automate intelligence, and then we'll apply the best practices. Excuse me. All right. So introduction to low code development. Now, and previously I've showed you what it was like to create a text generation application using Python and using code. And that's what we did when we developed our text generation app, which we used to generate the Lagos terminal and skyline view, right? Now, we had to write code for that, right? But what low code development means is thanks to AI, right? You don't necessarily need to write code. You need to understand what the code does. It's always a good thing to understand what the code does, understand what the language is and how the language works. But with AI, you can have AI generating most of that code for you, and all you have to interact with is the platform, the UI on the platform, which is what Power Platform does. It allows you use UI elements to generate your application. So you can write a code and then use prompts. You can write prompts and then use another prompt to further refine your application until you get to your desired outcome. So they revolutionize how we build application by providing a visual development environments that require minimal coding. So instead of writing thousands of lines of code, you can use drag and drop components to create a powerful solution. Now, The Power Platform empowers teams to build solutions through intuitive interface, transforming development timelines from months to days. This democratization of development enables both traditional developers and business users to create sophisticated applications. Now, there are different products for the Power Platform. So you have Power Apps, which can build custom apps. Power Automate, which allows you to automate workflows. So you automate your workflow if it's your ETL. So you're trying to transform, ingest, and transform data. So it helps you automate that. If you want to automate different components of your application, if you want to automate your API calls, automate your data storage, your cache, and all these different aspects of your application, Power Automate allows you to do that. Power BI allows you to do data analytics. So now this is where you develop dashboards. So you have your data sets and then you can make dashboards out of it to help your clients and your users understand what your data is saying. Now, Power Pages is an external website, and Copilot Studio is an AI assistant. Like I said, the AI assistant for Microsoft is for this Power Platform is Copilot, which is Microsoft's AI model. So you know how we have OpenAI and we have ChatGPT for OpenAI, and we have Grok for Elon Musk has Grok. We have Copilot from Microsoft. So what is generative AI in Power Platform? Now, generative AI integration in Power Platform enables everyone to build AI-powered solutions without data science expertise, right? It allows you to achieve through these primary capabilities, the Copilot and the AI builder. So the Copilot, like I said, is an AI assistant that builds solutions based on your conversational description, which is basically your prompt. You describe what you need in natural language, English, or Spain, or Spanish, Yoruba, and Copilot generates apps, flows, and the data models automatically. So it generates your apps, your flows, your API calls, the data models, it does that automatically. Now, what AI Builder does is a low-code AI capability that provides pre-built custom AI models to automate processes, predict outcomes, connected seamlessly to your data sources. So this is all right. This is a pre-built custom AI model. That's what AI Builder is. It allows you to automate your processes. So instead of having to develop your model from scratch, which you would have to do with PyTorch and TensorFlow and train your model on your own data, AI Builder already has custom models that you can just integrate into your data sources, which makes it easier for you to generate your applications and build from there. So Copilot and Power Apps. Copilot transforms AI development by understanding your requirements through natural language. Like I said, your prompts. You simply describe what you're trying to build, and AI Copilot gets it done. The AI assistant generates a responsive Canva app, complete with the dataverse data table, which is data storage, containing appropriate fields and sample data. You can refine everything through conversational steps. So through iteration of your prompt, let's say you got the first output, let's say you designed this first prompt, and I can show you what a basic, there's a platform I can use to show you what the basic it will design a website for us using a basic prompt. So I'll try and set that up for us at the end of the class to show you what it is like to generate applications and websites using basic prompt. So the key capabilities is your natural language app generation, automatic data model creation, sample data population. You can generate sample data and conversational customization. So based on your prompt iterations, you can generate or modify it. So if the first prompt, our first prompt gave us this image on our right, if we decide to change the color, change the look, with another prompt, we can do all that and get a better output. Now, Copilot and Power Automate. So Power Automate enables automated workflows between application and services, eliminating repetitive tasks. Copilot enhances this by generating flows from natural language. So you describe what you need, tell Copilot what the workflow you want to automate. So it could be like you want to make a to-do list app or a food tracking app. And so you explain what the flow should be like. The user inputs their weight, their size, what they want to be, what they want their weight to be like in 1 month, what foods they have, right? And then the application takes all that information, right? And then use all that to generate a workflow. So by the time your app is ready, right? By the time the user inputs all the information that the app requires, right? That workflow would give you the end result, which is okay. So, which our end results after we've defined our prompt would be okay. So, after we get all that information, we want our app to generate a training timeline, a meal prepare list, a sleeping schedule, a whatever it is you think your users will need to help them reach that goal by using a basic prompt to determine the workflow, okay, from information to processing to output. With a single prompt, we can generate an application. So Copilot creates the workflow with suggestion, actions, and connections. So even if you want us to connect application to microservices, like it could be an Google Maps. If we want to create an application that helps us track the traffic in Lagos, but we need a major source. So Google Maps would be like that data source because the big Google Maps has a generalized or a massive data set on the maps that we currently have in Lagos, right? So if we just want to take out Lagos as a portion and have that as our main app, right? So instead of using Google Maps that has the entire world, we just want to make a Google Map, a map version of just Lagos that focuses on Lagos because we want to Google Map doesn't have some streets. If you use Google Maps, sometimes it'll lead you astray. So if we want to get our fine-tuned map and decide to use Google Maps as our main data source, it would create a connection. So we'll make API calls and create a connection and we'll get the data and the information we need to expose it on our own application. So we can now further now customize before we now deploy our application and activate the automation process. So a real world scenario will be our education startup challenge. An online educational startup is experiencing rapid growth but struggling to manage operational expenses. They need a solution to track student assignments, processes, and invoice automatically. Right? The problem, the educators use spreadsheets to track assignments, which could be very, well, unmanageable. The finance team manually processes invoices, creating a bottleneck and errors. Now, our mission is to build a low-code solution using generative AI to create an assignment tracking application and automate invoice processing workflows. So I'm going to use this information and I'm going to take us to a platform that we can use to generate an application, right, based on our prompt. So it says building the student assignment tracker. So we initiate Copilot. Unfortunately, I can't access it for this class. So we're going to, but if you can, after this class, go ahead. It's a beautiful platform to use, but it just needs a lot of, so we navigate to the Power Apps, use the text area to describe the app we want to build. I want to build an app to track and manage student assignments. The Copilot will analyze your request and generate a database table where relevant fields like assignment name, due date, status, and student information complete with the same with sample data. So that's what database is, like a data storage. It allows us to generate our data, our fields, our columns, like an Excel file, right? And then it'll populate those fields with sample data for testing before we integrate it into our database, our client-side database, and then and then automates the workflow. So anytime a student or a teacher uh or a student submits an assignment, it will pop on our application that okay, this guy and this guy has submitted his assignment, right? And our data will include the date, the assignment name, the status, as teacher mark the assignment or not, student information, and so on. So what is Dataverse? Dataverse is a Power Platform's underlying data platform, a fully managed cloud service that securely stores your application data with built-in governance capabilities. So like I said, it's like that data platform. It's like you have Supabase, which is another platform that allows you to store data. So it is their own data platform that allows you to store your application data with their own built-in governance and regulation capabilities. So it's a cloud-based storage, role-based security, and role-based is like you determine who has access to what information. Students can have access to the backend information. So even if students have access to, if students, even if students are able to submit their assignments to the application, they cannot see what the backend is. Only teachers and admin can see what's behind the scenes, while it has rich metadata support and business logic validation. So enhancing app functionality. So we generate our app. So we click generate, create app, Copilot create generates a responsive Canvas app based on our specification. We then add the email screen. So we say, okay, I want to add an email screen to it. It will add the email screen to it. So I want to add a screen to send emails to the student, right? To create communicational functionality, it will do that. So this is just basically adding more features to the already existing app. So you can save your app and share to educators by entering their email address. So this is early stages when you're for testing to just see how the app does when you send it out to clients. So this is another component of the application. Like, so we said we want an application to track assignments and invoice information because that's what the finance team is having problem with. So the finance team is a centralized system to track invoices. We create we create a dataverse table to store the invoice data that will power an automated processing workflow. So we navigate to the tables in Power Apps, select tables and click the describe new table. We'll describe what we need. I want to create a table to store invoice information. Copilot generates fields like invoice ID, amount data, and supplier details and status. And then we create a table, review the structure, and click create to finalize the data model. And basically, all this is telling us is if we want to add this feature to the application. So we're making an application for a school, right? And first of all, we want the application to handle assignment tracking. Now, we also want the application to handle invoice tracking as well. So all this is telling us that using Power Automate, we can navigate to the tables tab, then we create a new table and using the prompt to specify what we want that table to do, and then customize the field. So we generate the field to have invoice ID, amount, date, suppliers, and the status. And once we create that create table button, it creates the model and we have our table presented. So trying to understand what AI Builder is. AI Builder brings artificial intelligence capabilities to Power Platform through pre-built and custom AI models, right? It enables us to automate processes and predict outcomes without data science expertise. And like I said, the AI Builder feature already has custom AI models. Now, all we need to do is specify what we want to use those models to perform, right? So you don't need to have data science expertise, know what code is, or have to write the code. The model already does most of the heavy lifting for you. So we have pre-built models, ready-to-use models trained by Microsoft for common scenarios like text recognition, sentiment analysis, document processing. So these models are already created for specific use cases. So they could be used for sentiment analysis that's trying to determine if the the text is positive, negative, or neutral. Text recognition, is it English? Is it French? Is it Spanish? We can use it to process documents. So if you want to process our invoice to extract the information that we need from it, those models are already made. So we can now further customize the models using our own data into we can also now use custom models, sorry, which means we are creating our own models, not using their previous models. We are training our own model on our own data, and we can bring those models into the AI builder space and use it to tackle our specific use case. And then it allows for seamless integration. So we can connect to data in Dataverse. We can connect to share the data via SharePoint, store it on OneDrive, or access it via Azure to power our AI-driven application. So it allows for seamless integration. And pre-built AI models right. Pre-built AI models available. So these are the current pre-built AI models that are available for use on AI Builder. So you have key phrase extraction, which extracts the important phrases from the text. Language detection, which detects what kind of language is inside that text. Sentiment analysis, the text positive, negative, or neutral sentiment. So whether so if the guy is angry in his text, we can text, the model can determine that if he's happy if it's neutral, the model can determine that. It can extract business card reader, extract information from the business cards, document processing, so extract information from forms, like so it could be uh if you have there's a word for it. But when you have people filling out forms for a certain use case, we can use this model to extract that information because we would have already specified what information we want to extract. So you can extract the people's answers. There's a word for it, but it escapes my mind. Then we have the invoice processing, which allows us to process invoices. So building invoice processing flow. Now, if we're going to use Power Automate to develop our invoice processing application, you navigate to the Power Automate and describe your workflow. So I'll process an invoice when it arrives in my mailbox. So Copilot will suggest the necessary actions and connections, and we click next to proceed through the steps and then create a flow to generate the automation. So basically what this is again, we're using a prompt. We're trying to explain to Copilot how we want the application to work. So as soon as an invoice arrives in my mailbox, I want the application to receive the process the invoice, extract the data, validate that this is the accurate data, and then proceed with the payment, right? So we're configuring flow triggers. So we could add triggers. So if we triggers in the sense that when certain things happen, you want something else to happen. So let's say if we want, like we use for that invoice, as soon as the invoice enters my email, we add a trigger. So that trigger triggers the data extraction process, which also now triggers the validation process before the payment process. So you set the email folder, configure the trigger to monitor your inbox folder for new emails with attachment. It filters attachment, enables only the attachment. Okay, so we can now add filters, attachment, enable only with attachment to ensure that the flow only processes emails containing invoice files, right? So this is another trigger. So we enable that, okay, only emails that have attached invoices in them are to be processed. And then we remove unnecessary actions, delete all the unnecessary text, condition blocks that aren't needed for the processing. So this is just configuring the flow trigger. So we could also use text generation in Power Platform to create text with ChatGPT AI model. We leverage the Azure OpenAI service to generate human-like text based on a prompt. So we could write essays, we could write customers, we can write emails, product descriptions, customer service responses. If the client has a request, we can automate a email reply. So if we want generate a professional email response and communication. So anytime a customer makes a particular request, we have a standard email response, right, generated by AI every time. So it's a, a word. So we can compile product descriptions, create compiling product descriptions at scale for e-commerce platform, and we can have power chatbots, customer service that respond to our clients because they're context aware and they have been trained on the company data. So this is how we use GPT in Power Platforms, similar to Copilot. So the best practices for GPT integration is we have to ensure we use clear prompts, right? To make sure our prompts are written specifically, detailed prompts that provide context and desired output. The more precise our prompts, the better the generated content. Iterative refinement, we can test and refine our prompts based on the output quality. So if the first output is not good enough, we can refine our output over and over and over and over again until we get our desired output. We need to implement error handling. This helps us to, you need to implement proper error handling and fallback mechanisms to ensure your flow remains robust and reliable so we can handle any crash or any upset that could come about. Because if you're familiar with code, there's always something. So if you don't implement proper error handling or fallback mechanism, your application might crash, and then you're left wondering what caused what to happen. But if you implement the correct error handling, you can see what is causing that crash in your application. And then also you have to manage your tokens, right? It's always important to mindful of your token limits and to optimize your prompt to stay within boundaries while maintaining quality. So you want to make sure you're not overusing your tokens and that even with the token limit, the output is still valuable and useful for your use case. So a quick knowledge check. A quick knowledge check will test the understanding of low code applications with these questions. All right, so what is the primary advantage of using Copilot in Power Platform? A, it requires extensive coding knowledge. It generates solutions from natural language descriptions. C, only works with custom AI models. It replaces the need for dataverse. So the answer is B, because Copilot enables you to build applications and flows from basic prompts. So just by writing a couple sentences, you have a full-blown application. Question two says, which AI build model would you use to automatically extract information from invoices? So you have sentiment analysis, language detection, invoice processing, key extraction phase. The question is, extract information from invoices. So the answer will be C, which is a pre-built model that allows you to extract specific information from your invoices. And then what is Dataverse in the context of platform? It says a visualization tool for data, no. B, a cloud-based data platform for sorting app data. The answer is B, right? An email processing service, no. And a code editor for developer, no. So like you said, it is Power Platform's data storage software or extension in a sense. So Dataverse is a fully managed, secure, cloud-based data platform that stores data for Power Platform applications. All right. And with that, we've come to the end to the class, but I'll quickly like to show you how you could design a website or an application using a basic prompt. So I'll stop my sharing my screen now, and then I'll open a website and we'll design a basic application, and then we'll call it a day. So.
Hello, Mr. Musa, are you still there?
Yes, yes, I'm preparing a little practical, so just to illustrate what I've been trying to show. If that's okay.
Oh, okay, that's fine.
Yeah, it'll be quick.
Okay.
All right, I have two practicals to quickly work through, and then we'll call it a day. So I'll go ahead and share my screen, and then we'll see what it looks like to build a prompt, build an image without using code. And then I'll show you a platform, a website where we can generate an application interface without writing code. All right. So if you can see my screen, we're back to the Azure platform. And now this is the Azure Playground, which allows us to generate images based on our prompt. So I'm going to generate, so instead of writing that code and using an application, we can generate our code using platforms like this. So I'm going to use a different variation for the Tomiland bridge. So generate an image showing. So let's see what this does. So instead of writing code, we have platforms like this, like DALL-E, Midjourney, that allow us to generate images. Now, if you can see, this is what that image looks like. And you can see the detail it has. Now we're looking from a viewpoint of a fisherman in the sea, right? This is still the Tubman Bridge, or also to say, right? And then this is the viewpoint of a fisherman looking from the sea. So like I said, we can use different angles, different takes, and different concepts. So that's for illustration of image generation using no code platforms. Now, I also like to show you building an application, right, without using code, just using text. So this is a platform called Builder.io, and this allows you to build applications, front-end user applications without code. So like I said, I'm going to use the context from our slides. So the problem is an educator's use, and this is I'm trying to generate a good enough prompt so that the application knows what we're trying to build. So educators use spreadsheets to track assignments which has become manageable. The finance team manually processes invoices, creating bottlenecks and error. So the mission is to build a low code solution using generative AI. All right, because this is an AI platform too. So to create an assignment tracking application and automate invoice processing workflows. I want to build an application that tracks manages student assignments relevant fields like assignment, due date, complete with the sample data. Also, also implement the finance team's needs of a centralized system to track invoices. I want to create tables to store information and information. So this is not the best prompt, but it's good enough for the use case for a while. So we're going to click send, and then we'll see what this generates for us. So as you can see, it's writing the code for us and it's generating the code, so we don't need to do anything. We'll just use our prompt. So I'm hoping that it would give us a detailed enough application just to illustrate the point. So here we go. We have a basic application, basic website built. Once it's done, I can try and show you all the pages and then we'll close. Almost there. It's not done yet. All right, see, so now the app is fully functional, beautiful, and ready to use. So we can look at the platform. Nothing here. 1 second. So here we go. We have all the pages. We have all our pages, total assignments submitted, the assignment name, student, subject, their score, what's overview. We have invoices, total invoices. So basically, we created an entire application just from a couple of lines of Word. Now, if I wanted to specify and create a lot of more detail into the application, I could just go back and just keep on prompting. I want to add another feature. And by doing so, once I press enter, it's going to do whatever I tell it to do. So that's one of the very important perks of AI is that it has made development a lot more direct and it does the heavy lifting so you can focus more on the planning, the execution, and all the other elements that still require us human beings to implicate or to imply. So with that being said, I hope I've been able to illustrate the point and show you what I'm trying to accomplish. And I hope you're able to understand the class. Uh, that being said, I'm going to stop sharing my screen. Thank you very much for your time. Thank you for the session. And I hope I've been able to impact you with some information, valuable information. Thank you again. Have a nice evening. Have a nice day. Bye.
Thank you so much, Mr. Mofe. That was really nice. We appreciate your time. Thank you.
No problem at all.